Hello and Assalamualaikum. I will not be available until week 14. Therefore, I will make a video for you to learn for the last two topics. So today I will show you topic number 14, which is differential equation. So the objective for this class is firstly to understand and create a function handle to available function. Then you understand and create anonymous function for mathematical expression and existing function. Understand and use the function, solve integration and differential using integral and different function. And lastly, solve differential equation using ODE 45 function. So we start with the function handle. Okay, so what is function handle? So function handle is basically a mathematical variable that can store and associate a handle to a function. With handle, a function can be called indirectly. Okay, the data type for this variable is written as function handle, and to create the handle for a function, preset the function name with an a sign. So this is the a sign. For example, here how to set y is set as function handle to a function my function. So you just put a or add. So the usage of this function handle is to construct anonymous function, pass a function to another function, or call a local function from outside of main function. Okay, we move on to anonymous function. So just to recap from previous chapter, okay, a function is actually a program that can accept input and return output. Okay, similar to standard function, anonymous function can also accept input and output. But the difference is, instead of program, anonymous function is variable. Okay, the data type of anonymous function is function handle. The operator, okay, the add operator is create the handle. Okay, anonymous function can contain single executable function. Since anonymous function is variable, saving the function is similar to saving a type of variable. Okay, you just use save. Okay, it is called anonymous function because the function doesn't have any name, while the standard function comes with a name. Okay, anonymous function is called indirectly upon when its function is handled. So how to create a anonymous function? So you just put a function handle name. Okay, what is the name of the function, and then you create a handle creator. You just put a or add, and then the input, and then lastly the function itself. Okay, executable function can be either one of the following, okay, mathematical expression or name function. Okay, the output for the anonymous function is not defined explicitly. Okay, so this is basically depend on the executable function. Okay, and so basically mathematical expression is single output argument, or name function can be similar to output argument with name function. Okay, I will show you some example explaining what is actually the anonymous function. So you can try example 13.1. So remember, just to recall back how to write a function. Okay, this is normally how you write a function. Okay, you write function f, which is the output here. This is the input. This is the name of the function, and this is the function itself. So, and you save it in M file. That is how you write a normal function. Okay, standard function. So basically this is from previous chapter. But if you want to write an anonymous function, okay, so instead of you creating a M file, you can just directly write it in the command window. Okay, So you just write the name of the function here. So so this is the input. Okay, the input is x, and this is the function itself, the expression of the function. Okay, so basically this one is this one. Okay, so if you see here, you create a anonymous function. Okay, with x as the input. So when you want to call back this function, okay, so you just write the output. Okay, you want to save where, and then the name of the function, anonymous function, and then the input. Okay, this is how you can use anonymous function. So let me show you the example in Matlab. So previously, in your previous chapter, you create a function. Okay, for example, y equals to, okay, what we call, for example, ddd. Okay, so ddd is the input, and the name of the function, this one. Okay, make sure you know what is the name of function. Is basically this one, right? So y is equals to the x power of 2 plus 1, for example. So you save this as the name of the function, which is ddd. Okay, save it. Okay, and when you want to call it, for example, you can call it, you want to save it as a, for example, a equals to ddd. So the x value you can put maybe 4. So basically y become a. So you will get the answer. So this is from the previous method, okay, the standard function. Okay, but how about the anonymous function? So for anonymous function, you have to delete this first. Okay, so let me clear this. So instead of you create a m function, you can create here ddd is equals to add. Okay, the function input is x, and give some space, and you can write the function itself squared plus 1. So basically you create a anonymous function called ddd. Okay, and the input is x. Okay, don't forget to put add, and this is the function itself. So you just press enter, it will create a function, anonymous function here. And when you want to call back the function, you want to save it, for example, at b, or okay, so you want to save it at b, and you want to call the ddd, and for example, you want the input to be, which is x equals to 3. Okay, this is the input, and you get the answer. So that is how you can use anonymous function. Okay, another use is of anonymous function is to name function. Okay, so basically you name the function so you can easily use it. Okay, so basically writing a available function as anonymous function is a way to simplify the function. For example, you want to use a mesh grid, okay, that accept vector as input and can return 3 output argument. So basically you want to create a mesh grid, okay, but usually you already know that you want to create with this function. Okay, only this is change. Okay, so you can use the anonymous function to set it up first, and you can use it easily after that. So you can try this, okay, for example 13.2, and make sure you submit your test coding inside the tutorial. So you can see here, okay, my grid, okay, equals to at x. So basically you have the input of x, and then this is the code mesh grid 0 to an input and 0 to 2. So basically you create a mesh grid here. Okay, so this is x. Okay, you have a 0 to something column, okay, and then 0 to something row. Okay, So basically you create a mesh. So you can try this in your Matlab. Okay, another advantages of anonymous function is to have additional parameter. So additional parameter is to the anonymous function are the variable defined in the executable statement diff but not declared as input as the function. So you can see here z is not declared here. Okay, so you can see here z is not declared, but the value of z must be defined before the anonymous function is created. So basically you have to define it. For example, before it is created, z is equals to something. Okay, this additional parameter will be useful to add extra variable for an input function of the functions. Okay, so next slide we will discuss of the functions. So we move on to the next part of this study, which is functions. So what is functions is it is a function that accepts function handle as input argument. Okay, so this is called a function. So since anonymous function is also a function handle, it can be used as a input to a functions. So later in this chapter, functions, integral and ODE are both example of the functions. Okay, creating a functions input for the function should follow the input argument required for the function. For example, here function integral is specified for the function input as below. So okay, I will show you example. You will more understand what is functions. So we move on to the next example 3.3, which is the functions. So you can see here, okay, I divide this. Okay, so this is the standard way you do this. Okay, remember you have to create a interval and then you create a function. You use the array operation, which is has dot, and you plot it. Plot the x value here and y value. This is the standard way you done it before. But if you want to use a function, you can use fplot. So try to Google it and know how to do the fplot. So fplot and plot is basically almost the same thing, but for plot you use x and y, but for fplot you use function and interval. Okay, so basically fplot is the function plot. Basically your input will be f and interval. So this one is the standard one. Okay, standard. But this one is the function. Basically you have a function of plot here and you have another function here. So instead of 3 lines, it become only 1. Okay, I think you first time saw what is fplot. So what is fplot? Basically, how to know it easily, you just Google it. Just write fplot at Google, and then you can see Matlab. It will explain what is fplot. So fplot is basically instead of plotting x value and y value, you plotting the function then the interval here. Okay, so this is example here. You have a function here. Okay, then you insert the interval. So if you look here, this is the function, of course, this is the function, and this is the interval. But usually the function, you need to have an input here. Okay, so this is what is function. Basically, you have a function here. This is a function, but inside there is also a function. Okay, so if you want to do the original way, this is the original way. Okay, so you can see here, you can get the result, but you have to code 3 times. Okay, 3 lines. But if you use the function, you can simplify the process. Okay, so basically this is the function you put here. This is the function, and you declare the anonymous function input, okay, at x, okay, which is the input here. And remember, fplot require the function itself. This is the function, and this is the interval. So for this one interval, you put it here, so you will get the same result actually. So if I copy this, okay, so this is this, okay, this is the first one. Okay, how about I create a second figure? Okay, so I put the function, automatically it will create the same result. So you can see here, this is the first one, this is the second one. So if you alternatively, if you don't want to use a function, anonymous function, you can use a function file. Remember that the function here, so you create a file here, .m file, okay, and then you can call the function inside the function. So this is basically this function, and you call it inside another function. So function within function. So I think I don't need to show you how to do this. I think most of you know. You have to create the myeq function file, and then you call the function file inside the command window. Okay, so still in the function. So basically you have a function here with c value, and you have to call the c value inside the function. So basically you have to create a plot here with multiple value. So you can copy it, try to run this in your Matlab. So you can see here, you will produce 4 results based on the same function, but in that function the c is different value. Okay, this is the c. Okay, that is how you create a function with additional parameter. Okay, slide in your attendance. Okay, now we move on to the next part of the slide, which is integration and differentiation. So this one is very useful if you have problems that involve integration and differentiation. Okay, you can solve that problem only just using Matlab. So before we continue, just take a 5-minute break. Okay, and we continue again after 5 minutes. So we continue with integral function. So if you recall back integral with this symbol. So you have function of, for example, fx dx. So how to do integral in Matlab? So basically you have to call the function called integral. Okay, and this is the function. You have to include the minimum and the maximum. So remember, this is mean, okay, x mean, x max. Okay, so this one function integrand specific to a function handle. So this one, and then lower limit, upper limit. So this one is the integral result. Okay, open your Matlab and start doing example 13.5. So the first example is of course integral, and remember you have to use the function integral. So how to create the function? You have to create an anonymous function. So easier to do anonymous function. Okay, so of course you have the function here, okay, this one with the input as x. So basically you write the function here. You can see here, this is the function. Okay, this is the same thing. Okay, maybe I just use a different color. So okay, you can see here, this is the function. Okay, this is the function, and then the input, which is x. Remember x. So this one, okay, because dx means that the function is the x. Okay, the input of the function is the x. So then you have to look at the input. Okay, so if you look here, this is the minimum, this is the maximum, so you put it here, the minimum first, the maximum first. Okay, don't forget the anonymous. When it comes to anonymous, you have to put at, okay, a or at. Okay, so of course you have to call the integral, and this is the result. You will get the result of the integration. Okay, so you can see here also the same thing. Okay, so you can try to do this. Okay, and of course you can try another function. Okay, any function that you can use. Okay, we move on to the next example. Okay, which is example 13.6. Okay, for example 13.6 is the application. Okay, so what is the function of integral? One of the function is to find the area under the graph. So you can see here the shaded region. So how to find it? Of course you have to use a integral. Okay, so given two functions of y shown in the figure above, find the area of the shaded region. So the solution is, if you recall back your previous knowledge, find xc. Okay, by finding the root. Okay, you have to find xc here. So basically finding when is y1 is equals to y2. Okay, so it is the root of y1 minus y2. Okay, so just this one. So basically the intersection point. And then find the area under both quadratic equation, y1 which is linear equation and y2 which is a 0 to xc. Okay, so you have to find the area here, and then you find the linear equation area. So if the area under y1 is q1, okay, and the area under graph 2 is q2, okay, here is q2, so the area of the shaded region is q2 minus q1. So basically you just plot until here. Okay, so basically you find the area from here to here. Okay, you have all of the area here. Okay, and then you minus this area, so you get the answer. Okay, so based on this problem, okay, you have to do a Matlab script. First thing, of course, you need to find the root. Okay, the root. So remember this one minus this one. Okay, you will find the root. Okay, basically you find the xc, and then how to get the area? Basically remember integral of the parabolic. Okay, and then you minus the linear equation, and then you just print the area. Okay, shaded area. So try to do this, try to understand it first, and then try to do it. So basically for the root, okay, maybe I too much. Okay, so for root you have to check back your previous chapter, which is polynomial, how to do this. Okay, so make sure you know how to get area under graph. Okay, maybe the question will ask you how to get the answer. Okay, now we continue our study with derivative function. So how to get how to differentiate function inside the Matlab? So basically you use diff. Okay, diff, and input array. Okay, x is the derivative order. Okay, and you have to divide by this. So basically this is just a approximate derivative. Okay, so I will show you the example after this. Okay, so we look at derivative example, which is example 13.7. Okay, so you have a function here. Okay, and you want to differentiate the function. So y, okay, t is basically dy t over dt. Okay, so try to remember back how to do this, and then you want to find the value from 0 until 10. So how to do this? Of course, you have to create a time, okay, because this is based on t. Okay, t is basically the time. So 0 until 10, and of course you have to put the interval. Okay, what is the interval here? And then you write the function here, and of course lastly, sorry, my mouse. Okay, so dy dt is basically differentiate the function y, which you already calculated. Okay, and you have to divide by the interval. Okay, make sure you don't forget to divide by the interval. Okay, so basically you will get the answer here. Of course, you have to plot the answer. Okay, time number 2 until the end. Okay, this one also number 2 until the end. So of course you have to plot the dy dt. Okay, so again plot it, and just one note. Okay, y and dy dt not always have the same size. So note that the size of dy dt always shorter by one sample compared to y. Okay, so this is the result of derivative. So basically, so this is the y, okay, and this is the derivative of y. Sorry, it is flipped. Okay, so this one is y, okay, and this one is derivative of y. Okay, okay, so remember that I say in Matlab derivative there will be a error, a small error, because it is just a approximation. So if you want to see how much is the error, you can run the example 13.8. So example here, this is the function, okay, which has order of 5. Okay, using this derivative divide by hash. So x is from 0 to 1. Okay, compare the result with the exact solution. Okay, so basically this is the function. You differentiate it. Okay, differentiate this function. Okay, using mathematical manually, you will get this. So try to estimate. Okay, we want to know if Matlab estimation is the same as the real function. Okay, real approximation. So to do this above, we have to write the script that estimate the differentiate of fx by settling hash equals to 1, 0.5 and 0.1. So remember, you have hash here, you can vary the hash and compare the result graphically. So remember, hash, you have to try 1, 0.5, 0.1 and 0.01. Okay, and the line style, of course, this one is just to differentiate this. Okay, you create a k is black color dot, and b is blue, r is red. Okay, so for n 1 until 4, so basically you have 4 result. So x from this one, okay, this step, okay, from 0 to 10, okay, 10 or 1. So it's okay, just look at the result, either 10 or 1. So hash can be either 1, 0.5, 0.1 or 0.01. So of course you insert the function here, the original function, not the derivative one. Okay, and then you differentiate the function. Of course you have to divide with the step, okay, step size. Okay, and then you plot the result with the line style here. Okay, and you put hold on. Oh, so basically hold on is Okay, if you want to plot multiple plot inside a graph, you have to put hold on. Okay, and then you do so you complete the estimation of the Matlab. So this one is the estimation of the Matlab. Okay, and then you plot the real one. So this is the real value. So this is the equation of the y function, the fx after it is differentiate, and then of course you plot the line here. Okay, and you give the title, of course the title, the label, and the legend. So a whole off is basically, this one is just optional. You basically just turn off the whole. Okay. Okay, now you can see the result. Okay, so you can see here the exact solution is this one. Okay, so basically this is the exact solution. So the error decrease when hash is become smaller. In this example, hash is 001, it give unnoticeable error. So basically hash, okay, when you differentiate, you put hash, okay, make sure the hash is small, okay, small enough, so you don't have a large error. So you can see here, if your hash, the step size is large, okay, the error will be very large. Okay, but if your step size, the hash is low, you will show almost the approximation of the derivative is almost the same as the exact solution. So be careful, derivative is not the exact solution, it's just the approximation, okay, not the real solution, but it still can be used. Okay, we move on to the next example, which is second order derivative. So basically second order derivative is just derivation, okay, differentiation for 2 times, okay, d squared y over dy dt squared. Okay, so almost the same, but remember the formula. Okay, if you look here, you have to include the level of derivative, as well as the step size. You need to have the power of 2 because it is a second derivative. So all the same. Okay, all the same, except that you have to add 2 at diff, and of course you have to put the power of 2. Okay, and of course be careful for first order. Okay, for first order you can see that the time is 1 sample shorter, but for the second order it is 2 sample shorter. So you have to start from 3 until the end. Okay, so basically for first order derivative, you have to you have to delete sample 1. Okay, sample 1 you delete for first derivative, but second order you have to delete sample 1 and sample number 2, sample of time. Okay, so you have to be careful. For second order you will lose 2 data. Okay, then after that you can plot it. So this one is important. If you don't remove the first and second one, you cannot plot it. You have error message. So be careful. For the first order you have to start with number 2, but for second order you have to start with number 3. So other than that, it is all the same. Okay. Okay, if you run this code, you will get this graph. Okay, if you look, okay, before I forget, so if you look at the bottom of the code, you can see here y dot phi hash, and the result will be this one. So basically, if you want to find what is y dot, okay, y double bar here. So when the value is 5, for example here, this is 5. Okay, what is happen if the value is 5 here? So if you use graph, so basically you get around 0.05. Okay, so this is from graph. But how about if you want to find it from the y dot? Okay, the data you already collected. So basically you have to divide by hash and plus 1. Okay, so here you can see here. Okay, for example, you want to find the value of 5, so y dot. Okay, you have a lot of data here. You want to find when the value is 5, but you have to divide by hash, and then you have to add by 1, so you will get the data. Okay, take a 5-minute break. Now we move on to the next part, which is differential equation. Okay, differential equation are very useful to represent a system. So basically, differential equation is an equation that involves derivative of function. You have multiple derivative of a function. So usually in system, they will present the system as this. So in Matlab, differential function can be solved using ODE23. Okay, so this is just a function here. Okay, it's called ODE23. Okay, you have to put the function here. Okay, function, and then this is the time span. Okay, this one is the initial condition. So y is the solution. This t is the evaluated time. Okay, so function to solve, specific as a function handle which defined as the function to be integrated. Okay, so basically how to write the ODE function handle. So basically, for example, I give you, this is a differential equation. Okay, dy dt is equals to 5y minus 3. So how to write this inside the Matlab? So basically, you have to, you can return it in anonymous function as something like this. Okay, something like this. Okay, like I said before, differential equation is very useful to present a system. And for this case, it is representing a charging of an RC circuit. So basically, you have a source here. Okay, so you have resistor and capacitor. So basically, you want to see the voltage across the capacitor when it is charging. So for example, 13.10, to find how the capacitor is charging, the differential equation above circuit using Kirchhoff current law. So basically, you do a Kirchhoff current law here. Okay, you do something like this, and you add it. So V in is equal to VR plus VC. So voltage across resistance and across the capacitor. So since this is negative, positive, so mid negative, and then for mid negative at the V in, mid positive at the resistor, mid positive at the capacitor. So that it's become like this. Okay, and then you change it up, you get RC VC here and plus VC. Okay, I think you already learned about this. Don't worry, usually for programming, programming for scientific, you don't need to understand how to get this equation. Okay, they will give it to you. So, but you have to make sure that you know how to transfer the solution into the coding, not to find the solution itself. So basically, at the end, V in is equals to, if let me delete this. Okay, the important part is the V in is equals to this one. Okay, and of course you insert the value here. Okay, you insert the value R, C, V in and VC at t equals to 0. So use this use the function ODE23 to plot VC from 0 second to 2 second. So how to transport this into a Matlab program script? Okay, so remember, like I showed before, okay, how to solve this equation is basically, okay, if you want to find the VC, okay, using ODE23, you have to make sure that okay, remember that the manual before, dy over dt needs to be a something y plus something. So you have to remove the first order of derivative at the left hand side. So basically, the first thing you have to do, rearrange the equation, like I said before, put the VC at the left side of the equation for the appropriate ODE function handle. So you can see here, it will already move here, and then you get this. Okay. So you have to rearrange, make sure this is placed here. And of course, you have to insert the value here. And after you insert the value, you get the final equation. So this one is a anonymous function. So remember how to write this. So you have to use this one. ODE fun equals to at Tn VC 100, okay, minus 10 VC. Okay, this is the anonymous function. So remember how to write it. If basically you have to add a name here at Tn VC, okay, and 100 minus this one is the equation itself. So recall back how to do the anonymous function. Okay, set the VC is equals to 0. So basically you have to set the VC, okay, any value. Okay, usually we put it as a 0. So basically it means that the voltage across the capacitor is 0. And of course it need interval, set a time interval. So basically you want to run it from 0 to 2 and write the ODE code. Okay, so you have to call the ODE 23. Of course you need to have the time and the voltage itself. Okay, so recall back the manual. Okay, you have to use the anonymous function. Okay, so I use blue to represent the anonymous function. So this one to this one is the anonymous function. Okay, and this one is time interval, and yellow. Sorry, my mouse doesn't work. Okay. Okay. Wait. Okay. So this is the initial value for VC. So what is the initial value for VC? So when you do this, of course you get the time and the VC for the time interval from 0 to 2. That's it. How to use the ODE 23. Okay, then you can plot the data. This one. Okay, let me clear this first. So basically this one, okay, this data you just plot this. Okay, of course you put the label. X label is the time, Y label is the voltage capacitor, you give the title, and of course the grid. So here are the result. You can see that the voltage increases until it reaches steady state. Okay, usually this one is the input voltage, which is 10 volt. Okay, which is similar to 10 volt. So basically this is the result of your coding using ODE. Okay, so basically if you want to analyze the differential equation with first order only, okay, you can use ODE 23. Okay, the previous example is the charging only, but for this case it's charging and discharging. So basically you have two conditions here. Okay, the first one is charging, okay, and the second one is discharging. So Okay, repeat example, previous example, which of the following V in. So previously is 10 volt, but now it is 1 volt V in. So above V in can be coded as 1 multiplied by t less than 1, or simply say that t less than 1. Only modification needed is the ODE function, okay, to replace the V in and the new equation. Okay, this one. Okay, so the solution is, okay, if you refer back to the example 13.9, you can get this equation. So if you look at example 30.9, is actually divided by 0.1, but if you simplify it, it will become 10. Okay, so this is the original formula, and of course V in is no longer a constant value, okay, and turn to 0 when t is more than or equal to 1. Okay, to solve this, we can use code V in either using decision statement or logical vector. So revise back what is the decision statement and or logical vector. Okay, so you can use either this way. So since anonymous function can only have one executable statement, okay, remember that anonymous function only can have one statement. Okay, so logical vector is used. Okay, so recall back, anonymous function only can be one function statement. So you can see that this one is means by one executable statement. So it cannot be very long. So the best way is just using a logical vector. So if you use the decision statement if else, okay, if you use if else or case, it will be very long. But if you use a logical state vector, it is very short. So how to do this is, here V in can be coded as 1, okay, remember the voltage is 1 multiplied by, this is the logical vector. Okay, you have the value multiplied by, okay, the value multiplied by the condition or logic. Okay, 1 when the t is less than 1. Okay, that's why it will become something like this. Okay, so V in is basically, so remember that the condition is 1 when t is less than 1, and the rest is 0. Okay, so that's why it written something like this. V in become 1 multiplied by t less than 1, but 1 multiply anything, okay, so it will be anything. Okay, that's why we remove the 1. Okay, so that is how you write with condition. Okay, if you have condition with your function, okay, you can use a logical vector. So I think many of you still don't understand logical vector. Please revise back what is logical vector. Okay, what is logical vector? This one in your test actually. So many of you cannot answer logical vector. Okay, so you include the logical vector inside the executable statement in the anonymous function. Okay, so of course you name the function. Okay, this one is how to make the anonymous function, and this is the function itself, the statement of the function. Okay, so this is, you understand that. So we move on. Similar to example 13.9, the initial is 0. Of course, this is the interval. You use ODE 23. Almost the same, but the only difference you have this one, and the voltage is now 1 instead of 10. Okay, previous example the voltage is 10, now is 1. Okay, of course make sure you try this example 11 inside your Matlab. So of course the same thing, you have time and the voltage, okay, time and the magnitude, okay, x and y. So you call ODE 23, of course you need the function, okay, and then the time span here, and lastly the initial condition, and then you plot it, label it, and add a grid, okay. So this is the result. So basically you charging it, okay, and then you discharging it. So I think this one is wrong, okay, since the voltage already changed to 1 voltage, okay, 1 volt should be only 1, okay. So be careful, if you don't have the same answer, okay, maybe the voltage is wrong. So maybe this one is 1, okay, check back. Okay, take 5-minute break before we continue. Okay, so we already see the first order, okay, which is y bar is equals to, sorry, let me delete. Y bar is equal to ay plus b. Okay, this is the first order differential equation. But for second order differential equation, so y double bar, that is mean by second order differential equation, so equals to ay bar plus by plus c. So this is for second order differential equation, okay, and ODE only can solve first order differential equation. So to solve second order differential equation, you have to make a two-stage differential equation, okay. So basically how to handle this, okay, basically you have to create a simple equation actually, but it is a little bit confusing. Okay, let me just show you here. Okay, so for example, you have something like this, okay, and to do this, okay, of course, okay, you have to assign something. So y equals to y1, y bar is equals to y2. Okay, you have to assign this. Okay, then based on this logic, okay, so first thing, so what is y bar? Okay, y bar is equals to y1 bar. Okay, so y1 bar, y bar is basically y2. Okay, so remember that the function can only receive first order. So y bar is equals to y bar plus b. So you can see here, okay, from this, you can see that y1 bar is equals to y2. Okay, this one. Y1 bar is equals to y2, and of course y2 bar, okay, so y2 bar, y double bar is equals to y2 bar. So you can see here, you only have one derivative, okay, first order only. So basically you reduce second order into a first order. Okay, that is how you can reduce the first order into second order. So you can see here, y double bar is basically equals to y2 bar, y2 a single bar. So y2 bar is equals to 2y bar. So you check back, okay, y bar is actually y2, this one. Okay, so this one is y bar is equals to y2 and plus 5y. 5y is, y is basically y1. Okay, and then plus 1. So that is how you reduce second order differential equation into something like a first order derivative. Okay, so how to write this inside the anonymous function? Okay, so how to write this inside anonymous function? Okay, make sure you know how to write this, how to reduce this into a first order, second order into first order. So basically, so this one you just write it here, but you have to put 2, okay, y2, okay, because this is number 2. And the second one, of course, this one. So 2 multiplied by y2, okay, plus 5 plus y1, okay, this is y1 plus 1. So this is how you create an anonymous function for the differential equation. Okay, and these both only represent a first order, not second order. Okay, you cannot solve second order in Matlab in this function. Okay, you have to simplify it into a two first order function. Okay, basically from from 1 second order, you make it to become 2 first order equation, 2 equation. Okay, this is only 1 equation. So basically this is how the first step you have to do. So next, after you derive the second order equation into the first order, okay, so how to transfer this into the ODE 23 that they can only receive first order. Okay, so how you do this? Of course, first, of course, you have to put the time span and the initial. Okay, so the initial is you have to put the initial for y1 and y2. Okay, so because there are two derivative now, you have to put the initial condition for y1 and y2. Okay, of course, for this case, you can put 0 and 0. And using the same concept, okay, using the same concept, you can use the ODE. Okay, add ODE t and y. Okay, so function ODE. Okay, for this case, okay, you separate this. Not the I think this one is not anonymous. Oh, this is anonymous. Okay. Okay. So this is not using anonymous. You just separate it only to a function. So basically, you can see here it written. Okay, make sure this is this one and this one. Okay, not this one and this one. So be careful. This one is for this one is for creating a vector. Okay, but you have to use this one semicolon, and then the second one. Okay, so this is how you write the function. So let me show you the second order. Okay, second order differential equation. So this is very useful for RLC resonant circuit. Okay, so if you, I don't know whether you already learned this or not, but basically when you do a Kirchhoff, okay, you analyze this, you will get this equation. Okay, so basically V in equals to RC V out plus LC V out double and V out. Okay, V out is basically voltage across C capacitor. So you can see here the highest order is double bar. Okay, so you don't need to don't need to find the solution, but you need to know how the solution can be transferred into the Matlab. Okay, so basically you have to make sure that V out bar V out double bar is equals to something. Okay, no more LC. LC will be moved to the bottom. Okay, so be careful. Okay, how to solve RSC resonance circuit? Okay, what is the first thing is rearrange. Of course, like I said before, you have to rearrange the highest order. Okay, so V out double bar is the highest order, and make sure you move the LC. Okay, make sure there is no other scalar here. Okay, be careful. Usually this one is forgotten. Okay, only this one, the V double bar out. Okay, the second order. So of course you have to put the value, insert the value. Okay, insert the unknown, and of course remember you have to define. Okay, define like this. Okay, remember that. Okay, the technique I show you. Let me get the pen first. Okay, so V1 is equals to V out, and V2 is equals to V out bar. Okay, so V1 bar, okay, V1 bar, okay, equals to V out bar. Okay, V1 bar equals to V out bar is basically V2. Okay, let me show you the. Okay, V1 bar is equals to V out bar, so V1 out bar is basically V2. So that is why V1 bar is equals to V2. Okay, how about this one is V1 bar. How about V2 bar? Okay, so V2 bar, okay, if you look here, so V2 bar, let me use the green back. So V2 bar is basically V out double bar. So when it comes to V out double bar, you look back the equation here. So this is V out double bar. Okay, so when V out double bar, you just copy back this equation. So 10 minus V out. Okay, so you look here. Okay, so V out, where is V out? V out is V1. So minus V1 minus CV out bar. So V out bar, where is V out bar? This one. So V out bar is actually V2. Okay, divide by 10C. Okay. Wait. Okay, now you already change the equation into the equation that can be understood by the Matlab, and then you set the initial, the time interval, of course the standard one, and then you write the ODE. Okay, you can see here there is a C. Okay, C is the additional parameter to the anonymous function. Okay, so C is anonymous parameter. Okay, unknown function for the anonymous function. Okay, so how to write this? So for this case, this one is the functions. Basically you have multiple value of C. So you have 50 microfarad, 100 microfarad, and 635 microfarad. Okay, and of course this one you just want to run for first capacitor, second capacitor, third capacitor. Okay, and then ODE equals to, of course, add T and V. Okay, the anonymous function. Okay, and then the function itself. Remember, don't forget the square bracket, semicolon, and then the close square bracket. Okay, and of course, because you have functions, make sure you put C and of course the N here, just to move the C, multiple C. Okay, so be careful. And of course the name of the function. This one you can use any function, any number, any name. Okay, you can call it anything. Okay, but make sure you call, when you call it anything, you have to make sure this is the same thing. Okay, of course this is the time. Okay, time span. This one the initial condition, because you have second order, you have two initial condition. Okay. Okay, if you recall back, this is the, if not mistaken, is the critical formula. Okay, not critical formula, critical frequency or resonant frequency, if not mistaken. So this one you just refer back. This one is not the something that you, not the Matlab equation. This one is just a theory in the RLC resonant. Okay, so this one will usually will be given. You don't need to worry. Okay, because you have to learn about RLC resonant to know this equation. Okay, this is the resonant equation. Okay, and then you subplot it. Of course, you have three subplot. Okay, remember subplot is basically you create a, okay, because this is 3, you have, and 1, so you have 3 row, 1 column. Okay, inside one figure you have 3 figure. Okay, so recall back the plot, and then of course plotting, and remember, okay, the data is not always more than 2. Sorry. Okay, remember when you plot. Okay, before I forget, so you, let me clear some of it first. Okay. Okay, for first order, it is easy because, okay, your y is only 1. Okay, 1 vector. Only one vector. Okay. But for, okay, vector, okay, let me show you. So if you have y is basically a long number. But for second order here, you have y bar, right? This one is okay. Your y will be 2 column. Okay, 2 column. So basically this is y bar, this is y double bar. Okay, your data will be 2. Or I think this one is double bar, this is this one. Okay, let me check after this. Okay, so be careful, you have multiple answer. Okay, so last thing, of course, the x label, y label, the title. Of course, you use s'printf because you have variable here. Okay, so when you have variable, you can use fprintf or s'printf, and of course, grid is on. Okay, so remember that I said that you take number 2, right? So if you look back, okay, y, okay, the y created here, okay, this one, okay, so y, if you look at the data, okay, check back the data, you can see that there are 2 columns. Okay, so which is which? Okay, how to detect that? Basically your derivation. So basically in your derivation, you said that v1 is v out and v2 is v out bar. Okay, so if you look here, v1, okay, so you can see here, you represent it as v2 here. Okay, this one is v1 bar. So v1 bar basically at the second places. Okay, and v, okay, so v1 is basically v out, okay, at the first places. So basically if you look here, this is the v out and this is v out bar. Okay, so if for example here, if you want to find the v out, so basically you have to look at the first one, not the second one. Okay, so be careful, if the second first order is okay because it's only 1 column. The y is only one column, but for the second order, the y will be two column. Okay, so you have to choose the correct one. Okay, so make sure you in your Matlab you run the code and you check the y. So there will be two column. Okay, the column is basically based on your equation. Okay, so if you look back, so this one should be 1, not 0. 1, not 2. Sorry, 1, not 2, because y, the second column is basically v out bar, but we want the v out, not v out bar. Okay, so this is the result. Okay, I'm not sure whether this is the correct result or not. Okay, I will run it again after this. Okay, so you take back the equation here. Okay, the code. Okay, if you run this, okay, you get the answer. Okay, so Ctrl V. Okay, of course. Okay, you look back here. See, if you look y, you have two number. Okay, so this is v out, this is v out bar. So depending on your derivation, okay, so for example here, this is the initial condition, right? So for example, if the v out is maybe around 0, maybe around 2. Oh, I cannot. Okay, maybe I create a script. Okay, so same as here. This is initial condition. This one initial condition for v out. Okay, this one is initial condition for v out bar. So depend on your derivation. So v1 and v2. So for example, v1 is, okay, if you recall back, v1 is v out. Okay, so maybe v out is 5. Okay, so you plot. Okay, remember to plot in 1, because you want v out, because the correct one is the first. Okay, you run it. Okay, so you can see here it start with 5 because the initial condition is 5. Okay, if 0, initial condition is 0. Okay, so basically this one is initial condition for v1. Okay, this one is initial condition for v2. Okay, depend on your derivation, you can determine the location. Okay, this is v1, this is v2. Of course, for y, this is v1, this is v2. Okay, so be careful. This one should be 1. Okay, if you want to try another electrical example, okay, other electrical example that use second order derivative, okay, second order differential equation, okay, you can look at the RLC parallel circuit. Okay, this is the differential equation. Okay, so basically this is the result of the ODE. Okay, you can try. Okay, I suggest you try to convert this. Okay, practice it, because this is a bit confusing. It is simple thing, but sometimes can be very confusing. So make sure you know how to convert from differential equation to the ODE function. Okay, and then you need to know how to write the ODE function, the anonymous method or function. Okay, depend on you. Okay, and then also the second order active low pass filter also use the same differential equation. So usually the differential equation is given. Okay, you don't need to worry, because this is not designing RLC circuit or the ODE low pass filter. This one is, I forget what is it, maybe control. Okay, you will not learn this, but it will give you the equation. You only need to change the equation into a function. Okay, So make sure you know how to change it. Okay, congratulations, we have finished chapter 13. This is the second last chapter. So next class we will learn a last chapter. Okay, so for today's class you already understand how to create a function handle, okay, to available function. So you also learn how to create an anonymous function from mathematical expression. So basically you convert mathematical expression to an anonymous function. Okay, and then understand and use the function. So basically you understand how to create a function inside a function. So basically these three is just a skill. You learn how to convert the written function into a Matlab script function. Okay, and then you will you're introduced to the integral. Okay, integral is much more simple. You just use the integral. And then differentiation. So of course this one you have to modify bit hash power of n, order of differentiation. Okay, so you have to learn. Okay, for this one you have two parameter. Okay, so make sure you recall back integral and differentiation. And lastly you learn about ODE. Okay, I think you learn about ODE 23, not ODE 45. ODE 23. Okay, and for this case you have learned about first order. Okay, first order and also second order. So make sure you know this skill. In the final exam, if not mistaken, you will given a question or from this topic. I think around 15 marks, if not mistaken. Okay, so I will check back and I will inform you the equation, the question for the final. Okay, so that's it for today. Okay, try to revise this. Okay, understand it. Okay, and see you again in the next class. Thank you.